Sergey and I talked a little bit about what I was going to talk about before coming, and I was like, maybe try to smush together two talks actually. Kind of one that is a little bit more in the background, so you're seeing the background talk right now, and then I'm going to very seamlessly segue into a little bit more of applied progressive web apps and explain a little bit more about some techniques and architecture patterns that you might find useful for building them, and also talk about some tools that I've been working on that could help you with that. So that's how we're going to structure things, and we'll have time at the end for questions and that sort of stuff. Okay, just fair warning, this part is a little bit more marketing-y and just what the background is, but it's going to get more technical as we go. So, all right. So in any case, it's a pretty exciting time right now for the web, and what's happening now is in a very similar way, no less revolutionary than what happened I think about a decade ago in 2005 when we started seeing like these Ajax-based websites kind of moved from having these static pages into something that can be really dynamic, something that people can interact with. And the user experience just went from just kind of clicking like on MapQuest to side of the map and you wait and things load eventually. It does another navigation to the experience where you could kind of have like the Google Maps experience of today and many other sites of today with like live panning and zooming, and expectations change. And you don't need to spend 30 minutes installing native map software anymore, which, if anybody kind of remembers the CDs full of your local area on a CD. And you don't have to wait for pages to load when you click. But this has been more successful in the desktop web historically than for the mobile web. So most folks kind of use Maps app on their phone and not the Maps website, for instance, and that goes for a lot of things. And what we see, and this is a research report that someone commissioned, saying that users currently spend most of their time in native apps on their mobile devices rather than on the web. And only 13% of users' mobile time is on the web, versus 87% in apps. Apps are more predictable, and that's one reason why people kind of like to use them. And they also have really good re-engagement features that historically mobile websites have lacked. So things like home screen icons that are easy to get on people's home screens, push notifications that bring traffic back to your web app or your native app. And you might take a look at this and think, okay, just go and build native apps. It's hopeless. But there kind of is a flip side to this, and something that folks need to think about. And this is another stat that 80% of users' time spent in the top 3 apps that they have on their phone. App usage is really, really highly concentrated. So users tend to only use a few apps, leading to kind of a winner-take-all situation. And based on user studies that have been done, people see native apps installation as like a really big commitment in terms of space on a device, in terms of time and going through the whole flow of going to a native app store and installing things. So, native apps may be engaging, have some advantages there, but users kind of consider only a few of them worth installing based on what kind of research has shown. So one way that you can think about the difference between native and web apps is on this like capability access over here. So for instance, like native apps have the ability to start up reliably when you tap on their icon, and they boot up quickly, and they tend to work offline, and they can send push notifications and sync in the background, and they have access to sensors like your microphone and camera. But on the other side of things, the web tends to historically be safer and historically a little bit more respectful of privacy than native apps might be. But it lacks some of those kind of deep engagement features and the ties to the native operating system. So one of the things that the web is really good at, though, is being way out on that reach side of the spectrum, side of the axis. And you have just huge reach with a website and a lower barrier to entry to get people to try it. So again, to back this with a bit of data, seen 0 number of apps for the average user installs per month. Obviously, it's more than 0, but we're rounding down a little bit there based on this study. So by contrast, though, mobile users visit over 100 websites per month. And this is really kind of like the power of URLs in the web. They're really good at meeting one-off needs historically, so that's great. Getting people to go to your website is a much easier problem than getting people to install your native app. So, we've kind of been thinking at Google and other browser vendors, what if we could add the capabilities we need and the web can meet the user experience expectations that users have from a great native app. And then we can kind of get to the point where we kind of have the best of both worlds, where you have both the capability and the reach for the web platform. So we want to get to the point where the user experience is good enough and integrated enough to earn a place for a web app on your user's home screen and also in their notification tray, and not have to give up the reach in order to get that. So that's kind of long-winded, kind of businessy justification for what we're talking about here. We see the concept of progressive web apps as just an encompassing vision of a whole new level of caring about the quality of the end-to-end user experience, really. So if you forget everything else, just think about it as like this idea that we could bring all those wonderful capabilities and provide a great user experience without sacrificing the reach of the web. So, in order to build that new level of experience, though, we need to improve the applications that we're building for the web. So web apps need to be reliable, and they also need to have reliable performance. We've kind of become used to always being online. So when we see the downosaur or the offlineosaurus or whatever in Chrome, it's kind of a disaster. And we're also in the situation. Someone mentioned this before. We got Li-Fi, so it's kind of made worse by the fact that phones are in a constantly changing state of cellular network connectivity. So even if you have full bars, you may not have a live connection. This lies to you many times. So this is also means that it's really slow. You could be on, a LTE network, and you just happen to be deep inside a building in Manhattan, and you know, barely getting enough bandwidth through to load things. So this is something else that we have to fight as developers of really high class, high quality progressive web apps. So, native apps never show us this dinosaur. Nothing that I use regularly shows this. They have a great ability to show you something, even when you're off the network. And in order for web apps to really earn their place on a user's home screen, we need to make them reliable even when the network isn't. So secondly, users don't expect janky scrolling or slow loading apps. They really want something fast, and they've come to expect it from their native apps. So the web historically has had a bad name for slow performance, particularly on mobile, and especially when it comes to loading. So think of it as underscoring the previous point about reliability. It was super dependent on the quality of the network that you happen to be on. Another stat for you, studies have shown after 3 seconds, 40% of folks will abandon the experience if the site hasn't loaded. This means that loading a web app really has to be invisible and feel instantaneous, just like a native app. And finally, a great user experience really needs to be able to engage users. And there's a few different things we could do here. Needs to feel immersive. So we need to have web apps that give developers the ability to remove the URL bar to create a full screen experience if that's what's right for your web app. You want to be able to control the kind of the theme and the status bar for folks who are on Android. You might have seen the ability to customize those colors and have that show up in the app switcher there, just like native apps could do. And also do things like managing device orientation. If you happen to be working on a particular web app that really only makes sense when you're in landscape mode, for instance, we need to give developers control over that. It also needs to have a proper place in the user's home screen, and that means a high quality icon and things like that, and metadata about that web app. And we need like a really nice mechanism to prompt the user to save the app to their home screen. This ideally would not be a full screen pop-up asking people to do things. So this is something that the Chrome team has been thinking about along with other browser vendors, of like good UX for making that experience work for users. And we also need to be able to re-engage users through push notifications. That's super important. Push notifications, unfortunately, is a super huge topic that I'm not going to get into in great detail at all tonight, but I'll have some resources at the end that have more information about folks who want to implement push notifications on the web. And it's getting easier than it used to be. So, all right. Hopefully, that's a little bit of a motivation and folks want to get started. And it may seem like a lot of work, but I want folks to walk away understanding these new capabilities. And I also want you to be able to make the case, on the businessy side, if you happen to be a developer at a larger company, as to why it's critical to invest in the web platform. Um, and it doesn't have to be a huge undertaking. What we're talking about tonight can be broken down into smaller pieces. There are ways of kind of taking a piecemeal. This is in some senses the progressive as part of progressive web apps. You can add things on as you go and get a gradually better experience for your users. So we're going to kind of break it into a few key pieces, and I'll dive into one of them a little bit later. So first of all, you need security. I really hope that I am preaching to the choir here, and I don't need to convince people that HTTPS is a good idea. Please enable HTTPS for your website. There are steps you could take to make sure that nobody ever goes to the HTTP version of your website, and strict transport security, things like that. This is super important. It is something that is really the first requirement in building a progressive web app, and really just doing modern stuff on the web nowadays. Things that are powerful and kind of tie in particular to the device's sensors, and have the ability to kind of write to disk, as you could do with some of the caching stuff we're going to be talking about. Browser vendors, including Chrome, have said, okay, we're only allowing sites that are served via HTTPS to access these features. This mitigates the danger of things inserting themselves in the middle and taking control of your device maliciously. So HTTPS is a good thing. Hopefully folks have, if you're in a corporate setting, you probably have some big commercial SSL cert vendor. If you are just looking to do this for your own smaller sites on a custom domain, something like Less Encrypt is a really great project to try out. Free certificates, definitely check them out. But just for playing around, for kind of small projects, for prototyping things, there's a lot of options nowadays, and it kind of means in some cases sacrificing the custom domain, unless you kind of have something proxying in the middle. But using GitHub Pages, using Firebase hosting, using any of the number of other kind of hosting services out there that are all like HTTPS by default or HTTPS only, is a great way to kind of put something out there. All right. So first time I'm mentioning service workers tonight. There's going to be a lot more about it later, and I'm going to kind of gloss over it a bit here. But service workers are key to kind of having a great progressive web app experience. You could think of it as a JavaScript proxy that kind of sits between your browser and the network. And the page registers a service worker for a given origin and scope. And then that service worker code that you write has the ability to respond to different events. And you have full control over caches, and you could do things like avoid going to the network entirely and just go to the cache for your resources, and have smart versioning in the cache and things like that. So we'll be talking a lot more about this and using some libraries that I've worked on for powering your service worker and taking a lot of the hard work out of generating a service worker a little bit later. But keep that in the back of your mind. Service worker is super important. And finally, engage your users. Once you're using HTTPS, once you have a service worker in place, you can kind of unlock these other user engagement features that have both HTTPS and service worker as a prerequisite. So add to home screen is one of them. Um, this is, I don't need to tell you the importance of having your web app on the home screen, but the current experience of getting your web app on a user's home screen is kind of broken. You kind of have to, in this is Chrome, on Android, and it's a little bit different on each platform, which is part of the problem. Users don't necessarily know what to expect. But you have to kind of like dig a little bit in this overflow menu. And, even if you do find that add to home screen option, um, what you're really adding to the home screen is like the current page that you're on. Like if you're a news organization and a user is reading an article, and they go to add home screen, they're adding that article to the home screen. They're not adding like your web app, and they're gonna, you know, open up the news from 2 years ago whenever they click on that article, which could be depressing. So, and also just there kind of wasn't an expectation that when you did add a bookmark, what was effectively a bookmark to a website to your home screen, people don't really assume that it's going to work offline. They think, okay, I have this thing bookmarked. It's not really an app experience. If I'm on the subway, I wouldn't think to go there and click on it and for anything meaningful to happen. So there's kind of just this user expectation of a poor experience you kind of have to fight with. So to kind of fix some of these issues, we're rolling out a standardized way of kind of prompting the user to add to home screen. And one of the things that you as a developer need to do in order to get that experience is to tell the browser about your app, basically. So there's nothing super controversial in here that probably take you things by surprise. You just have this manifest format with some JSON data. In this particular case, it's like the Washington Post web app, and this controls what the experience is like when somebody does add the web app to your home screen. You get to choose the icon. Really importantly, you get to choose like the start URL. I would say whenever they go here, always go to my main index rather than whatever page they bookmarked. And then you just get some of that other control that I was talking about earlier in terms of like orientation, being able to lock in that and hide the URL bar, set some theme colors and things like that to match your branding. So, pretty similar experience to what a user would get if they were to open a native app from the home screen. So that's great. But I alluded to kind of getting the user to install it has been a problem historically, either because you might go on one end of the spectrum where you're way too pushy and you have an overlay saying, hey, do this, install it to the home screen, or more likely, hey, go to the App Store and install our app, which users probably not going to do. Or you don't tell users at all that they could add it to the home screen because you think, oh, it's just part of the browser. If the users really wanted to add it to the home screen, they'd go into the overflow menu. Users don't know how to do that on average. So Chrome and other browsers are following suit. It has this kind of experience that will automatically be triggered by certain heuristics. It's not going to be shown like the very first time a user visits your site, and this is all being tweaked. It's been live for about like a year now, and I think it's undergone pretty much like quarterly changes to the algorithm. So it's a lot more aggressive than it used to be in terms of getting that little pop-up at the bottom that gets shown by the browser itself. This is not something that you need to implement. But yeah, it's tried to be implemented in a way that will not annoy users the very first time they visit your site. It'll just, after there's some repeat engagement, at that point it'll say, hey, by the way, you could add this to your home screen. And hopefully by that point, your users will actually want to click on that add to home screen button because they've had a chance to interact with your site. They like it if they've come back, and they'll find it valuable. So, that's a lot better than just forcing a user to go to a native app store and install something blindly that they've never tried before at all. So yeah, it's also kind of a recap of the more marketing-y portion. Staying secure, super important. You need to use HTTPS. You need to have a service worker. We'll talk about that in a second. And you'll be able to, at that point, use these features to engage your users to drive traffic back to your application via respectful, hopefully, push notifications, and get placed on the home screen, and just really make it feel as if it were a the same sort of experience that you get from an installed native app. So, the progressive portion in progressive web apps is a very overloaded term. Kind of means what you want it to mean. I mentioned that it's, one way of looking at it is that you could progressively add in additional features. You could, if you're not using HTTPS right now, you could start, and please do, start by adding in HTTPS. You could slowly add in an offline experience with the service worker. You could then add in, the manifest information and things like that. You take a little bit at a time. But kind of the other way of looking at progressive apps is that everything that we're describing is kind of like progressive enhancement, and not all browsers support all the functionality we're going to be talking about. And we want folks to kind of take the ideas behind progressive enhancement and backwards capability in mind when they implement this functionality. So we're going to be talking about some best practices that'll work even for browsers that don't support service workers and just lead to a better experience. And everybody will benefit from HTTPS and things like that. So that's kind of one half of the progressive story. And just really the overall idea, and it is a little bit of a marketing term, progressive web apps, but it's just the theory of taking the next step in caring about the user experience and really matching what you could do with native apps today. And I'm going to talk now about how you can actually go about and build those. So this is going to be hopefully a smooth transition. But give me a second here, and I'm going to try to guess where my mouse is. All right. All right, and give me another second. All right, so I'm going to spend a little bit of time now talking about one application architecture that you could use when you're building a progressive web app, and particularly it's something that has a service worker. And we're going to also dive into using service worker tooling to kind of create a fast offline first experience for users of your web app. So this is the tools portion. Yeah, so what I'm going to be describing is what we're calling an app shell model of building a web app. And the app shell architecture works really well with service worker caching, especially, treat the service worker caching as progressive enhancement. It also works well when there isn't a service worker. And I'm going to go into some detail about the SW precache and SW Toolbox libraries, which make it really easy for developers to add a service worker to the website. And these are two things that I've been working on for the past couple of years now, actually. And the really nice thing is that web apps that use the app shell plus service worker model can effectively feel like they load instantly. And this is the experience that you want. This is the experience that users expect from native apps. We could bring that to the web. So let me just demonstrate what I mean with an example I put together, kind of real worldy. It's obviously a demo that I put together, so not entirely real worldy, but yeah, I built this web app for browsing iFixit repair guides. Just kind of indicative of the type of web app folks might want to build that's for browsing content using a public API. In this case, the iFix API returns kind of this mix of text and images like you'd find in many other content browsing applications. A little screencast or animated GIF go in there. So we're using the iFix API to load in a list of featured guides, and then we're browsing through a few of them. You could imagine each of these pages as being something a user is discovering on the web as a search result or via URL linked to from like some other random article. This is the web. There's nothing special going on here. Each of these things has a URL. You don't have to install anything in advance. Users can go directly to the individual pages. And loading kind of looks fast, but let me put some actual numbers behind a few different loading scenarios to kind of motivate the point here. So all these examples were run on a simulated 2G network against the App Engine deployment where I'm hosting it. and we're showing off top-level navigations. Just incidentally, Chrome has pretty good tools for simulating slower networks. Those tend to work pretty well. I mean, nothing could perfectly simulate a given network, as each network is messed up in its own unique way, I guess. But um, it's pretty useful if you haven't tried that out. Chrome also has some tools for kind of like throttling your um, performance to try to match that of a specific like low end device. It was a little less successful. So testing all the things that I've kind of did for preparing this talk, I did like generate screenshots and stuff, using an emulated instance, but testing on real devices on real network conditions is super important throughout. So that's just keep that in the back of your head, not just for this talk, but in general. There are things that behave one way on your, MacBook Pro that behave very, very differently on the type of devices that your users might be using. All right, so out of the way, this is kind of like the experience loading the web app for the first time with nothing in the cache, no service worker involvement yet on a simulated 2G mobile network. So we're able to get above the fold content on the screen, a very respectable 650 milliseconds. That's not bad. We're actually shipping down full HTML in this case. It's not like rendering on the client. So not bad. So let's compare that first visit to what your users would experience if they next time they visit the same page, once the service worker is in place and cache has been populated. And we're able to get the content on the screen, in this case, in about 200 milliseconds. So saving 450 milliseconds at this point. And as a point of comparison, same page load with a populated cache, like using the HTTP browser cache, but without a service worker, takes around 560 milliseconds. So there's a win from having a service worker there. And let's see why. So let's take a look at, before that, let's take a look at the loading experience for a page that we haven't previously visited. So we're assuming that there's a service worker in place because a user has gone to your site before, the service worker has been installed. And it does things like cache the app shell, which we'll be talking about soon. The nice thing is that this benefits new page loads as well. It's not just the things that you've visited before that are can be faster. It's also just going from page to page and brand new navigations that can be faster as well. So here we get above the fold content on the screen in 225 milliseconds, and that's compared to 650 milliseconds if there is no service worker in place. So you can see that even on a slower mobile network, load times are really good across the board. And there's a real reason for this. So like regardless of how you structure your web app, whether you're doing app shell, whether you're doing server side rendering, no matter what, the initial request for HTML landing page for the navigation request can take time. So on the left for network traffic, you can see from the kind of a screenshot of, hopefully you can see, yeah, from the Chrome network panel. When we go to sample app for the first time, when there's no service worker and there's nothing in the cache, it takes 423 milliseconds in this case to get a full response. So this includes the time, in this particular case, for like the server, the app engine server that's running it to request stuff from the fixed API. So there's a little overhead there. But on our right, we're serving the same page directly from our cache via the service worker. And that same request takes only 5 milliseconds. So the surest way to make sure that your web app is not going to have unreliable performance is to try to take the network out of the picture. Even if all you're doing is sending a very lightweight, like cache revalidation request and getting back a HTTP 304 or something from the server, that could take an indeterminate amount of time depending upon what network you're on. So if you can avoid that entirely, you will get a much, much more reliable, almost instant experience for your users. So we really want to get to that goal as web app developers, hopefully. So, all right, so let's talk about how we can build that. hopefully everyone's out there and ready to go and adopt this model for your own web apps. But let's just run through an explanation of some key concepts first. First up, app shell. I mentioned it before. What do I mean? Think of it kind of as like the HTML, the JavaScript, the CSS, and any other static resources, any images, things like that, that provide the structure for your web app, um, minus the actual content specific to a page. So the idea behind the app shell is that it should be cached. You can use a service worker to make that particularly efficient, and it should load quickly. And you can kind of think of the app shell as being equivalent to the type of native code, um, like with the views and layouts and things like that. I don't know all the terminology that you would upload to the App Store. If you're writing an Android app or an iOS app or whatnot. So you again, just to drive home the point, if you are writing a native app for like a newspaper, you're going to upload everything for showing your navigation and for your basic structure. You're not uploading news articles to the App Store. Same deal. But unlike with native apps, you can deploy updates to your app shell in seconds. There's no gatekeepers to go through. And the concept of the app shell is going to come up again and again throughout the presentation. And I kind of went with this like color coding thing to kind of drive home the point. So anytime you see something green, um, it's going to be something about the app shell, basically. So the idea is that you have this HTML, files, app.js, and that equals your app shell. Right. Once the shell content loads, we fetch the dynamic content particular to a given URL. In our particular case, we're using the iFix API to fetch that content. Zoom in, that's what network request looks like. And to populate the view, and then you get some things on the screen. And the kind of formula is the app shell plus our dynamic content equals our complete rendered page for this type of web app. And anytime you see something colored blue, I'm talking about dynamic content. We have our full page. All right, so I've alluded to them before. You've probably heard a lot about them if you've been paying attention to various things going on in the web development community for the past like 2 years-ish now. But what's a service worker? I say that, please don't feel bad if you have not heard of service workers before. They're super cool, and go into a little bit more. So they're a network proxy that you write in JavaScript, and they intercept HTTP requests, and they can do a bunch of other things, but they're really event-driven. So whenever there is an HTTP request, it fires an event in the service worker. And when the service worker script is installed for the first time, it fires an event. And it kind of sits in the middle of things. And an analogy that I kind of like to use is think of a service worker as being like an air traffic controller. So the idea is, well, let's kind of like take this analogy to its conclusion. You could think of your web app's HTTP requests as planes taking off. The service worker in place, you kind of have this air traffic controller making sure that your requests land quickly and efficiently. So request planes might land using the network runway, and that's fine for certain types of requests going against network. Probably makes sense. Or they might land using this cache runway, in which case you can bypass the network completely, and that's great. But the really cool thing is it's up to the service worker, and therefore it's up to you, code that you control, to decide how to handle each request. So you have a really, really, sometimes overwhelmingly, amount of power to determine how your web app is going to perform, which is cool. So let's also just talk a little bit about the life of a service worker, because it's a little bit different than some of the concepts you might be familiar with unless you've played around with web workers before, in which case this is going to be sort of similar, but there are some differences there too. So All right, so the basic idea though is that your users start out on a page. Very first time you navigate to a page, there's no service worker that's in place yet. They don't get like pre-installed, for instance. So you navigate to the page for the first time, and then there's some code to kick off the service worker registration that you put in your web page. You have to explicitly say, like, I would like to register this service worker. This creates a new service worker instance, and that fires the install event on the service worker. So, kind of getting to the code that your service worker runs at this point, and you could do things in your service worker in response to this install event, like have a manifest of or list of everything that you need for your app shell, and then cache it. And the cache that you have access to is something different than the browser's HTTP cache, and you have a lot more control over the entries in that cache. All right, so this is our chance to add things to the app shell content to the cache. Let's dig in deeper a little bit. For every setup, have a completely separate URL scheme and things like that. In this particular case, we're serving the HTML for app shell from the /shell URL. So you'll see that throughout the presentation. You might see things for /shell. This is the HTML for our app shell. So keep that in the back of your mind. So to populate our cache, the service worker makes an HTTP GET request for /shell. So regardless of what page the user is navigated to, like they might be on, page /blah/1234. Our service worker is going to make this request in the background in a separate process or thread, depending upon how things are implemented, for /shell, and it's going to populate the cache with the response. And here's just one way that I have my app shell set up. Let's walk through the contents a little bit. We're including some site-wide inline styles that will be shared by all our pages in our app shell. Kind of have this template insertion point within our body for the app shell where we're putting in the actual content. It's a placeholder for some client-side templating once the dynamic content gets loaded. So we're going to stick that in. And finally, we include a reference to an external file, app.js, that contains the site-wide JavaScript that our page needs. So again, this is just specific to my sample application. Your own site's gonna be a little different. Kind of depends on which frameworks you're using, if you're using frameworks, and how you have your site set up, but the same concepts apply. All right, so back to life of the service worker for a bit. Next event you'll get a chance to handle is called Activate. And this is where you would normally perform cache cleanup of any out-of-date resources that your shell no longer needs. So you kind of have first the ability to handle the install event and download new things. Then at some point later on, it might be immediately, it might be a little bit after a delay, depending upon whether you have any open tabs with your page in another browser window and just a different tab. There's ways of delaying it so that you don't delete the resources that a previous open version of your web page needs. But the general idea is this is where you do cache cleanup. So you have the ability to make sure you've swapped out the branding images for your site, delete the old one from the cache. You don't need that anymore. Save space on your users' devices. And kind of once those event handlers complete, your service worker enters into an idle state. It's running and it's a separate process or thread, but it's not really doing anything until there's a network request that originates from the page. And this might be any type of network request, actually. It might be like an XHR, it might be using fetch from your page. It might just be like you have an image tag with a source. That will also fire an event that the service worker could respond to. And your service worker gets a chance to intercept that request and respond however it sees fit. So it does that, responds to a fetch event, but then you kind of go back to the idle state again. So it does that a few times, and then there's some logic in place, and this is kind of specific to each browser and specific to each platform as to how aggressively it's stopped. But the service worker thread eventually is killed, and this just makes sure that there's not this background process that stays running on the user's device, doing who knows what. indefinitely whenever you visit a single web page. So people will hopefully appreciate that. Your users will hopefully appreciate that because this is something that is super powerful and has the advantages of running separately, but we don't want this to run forever. Um, so next time that a network request is made, it's started back up again and go to the fetch event handler, and this kind of repeats itself, and it can immediately respond to fetch events at this point. And my previous air traffic controller analogy probably breaks down a bit because you wouldn't want to like tear down and rebuild your air traffic control tower each day, but you get the idea. Um, so yeah, let's take a look at how our fetch handler can serve up our app shell. So this is JavaScript code responding to a specific event. You actually are doing add event listener fetch, blah blah blah, and then you could write your code. In our particular case, our service worker can intercept requests for any URL under its scope, including pages that haven't previously been visited. So the scope is kind of the concept of when you register the service worker, you have to say, this is the section of my origin, basically, that I want the service worker to control. Any navigations to pages underneath the scope will automatically have the service worker in place. This could be kind of useful, like if there's a section of your site that you don't want the service worker to interfere with at all, and just as long as you have a kind of sane URL structure and you're able to just specify like a scope of your site for the service worker control, it's one way of doing it. So in our particular case, though, what we want to do is respond to any sort of navigation request for anything in our whole URL structure with that /shell response that we've cached. And this will bypass the network completely. So in this case, they're going to /guide 456, fetch event by the service, intercepted by the service worker, and the service worker doesn't go to the network at all in this case. It has the HTML for the /shell already. It has our JavaScript and our CSS stuff cached already, and it's responding to the client page directly from the cache. So no network involvement. And it's kind of like a model of like responding to any sort of URL, kind of with like this type of single response HTML. It's something that you might be kind of familiar with. Sort of what happens with server-side rendering when a URL pattern is routed to like a matching. You might have like a wildcard that routes everything to one matching handler, and that's responsible for returning the full web page to the browser. So this is kind of like the service worker equivalent of that. And it's code that runs client-side in the app shell that ends up populating the content once it gets the shell back. So if you're using, the nice thing is like if you're using like a universal-ish JavaScript framework, it might be the same templating code that runs on the server for doing server-side rendering as what runs on the client for kind of populating the body of that app shell once you have it back. So theoretically, you can share a lot of code there, and it doesn't mean writing a bunch of new things or maintaining two different code branches. It's not a requirement though, but a lot of folks I know are probably in that boat where they're doing things with universal JavaScript nowadays. All right, so at this point, hopefully you see some of the advantages of structuring your web app using the app shell along with the service worker model in terms of being able to bypass the network completely and getting content on the screen. And you could write your own service worker code, and I encourage folks to go out and do that for especially like educational purposes as you're getting familiar with the API. Don't just use libraries and not understand what's going on under the hood. But for kind of production-y web apps, I would kind of recommend either getting super confident and comfortable with service worker code, or alternatively, trying out these libraries that my team works on. So they take care of many of the details for you while following best practices and avoid a lot of common gotchas and ways of shooting yourself in the foot. There are lots of ways of shooting yourself in the foot when you're basically acting as a proxy for all network traffic that's coming from your web app. You could do things that are not so great, and there always are escape hatches. You're not going to get yourself in a situation where your users are permanently in a bad state, but you don't want your users ever to get even temporarily in a bad state, ideally. So, all right, and we go back to our analogy again. You may be an awesome web developer, but you may not feel comfortable writing the code responsible for landing an airplane, and that's okay. So the first tool that you can use is SOV Precache. This takes care of caching and maintaining all the resources in your app shell, and really anything that's kind of like a static local resource that your web app might need. And the second tool is SW Toolbox, which provides like a canonical implementation of all the runtime caching strategies that you might need for your dynamic content. And we built these libraries to go together hand in hand. They really use them together, and it gives you a service worker that could both load your app shell instantly while also giving you fine-grained control over how your dynamic content is cached, and gives you the ability to treat different types of dynamic resources differently, which is pretty cool. So, all right, so let's dive into the first library. I have a gulp graphic on the screen. I guess it's the end of 2016 and not everybody's using gulp anymore, which is fine too. There are other ways of using this, but for this particular example and for the sample code, I have a gulp-based build process. And most websites, certainly most production-y websites, already have some sort of build process in place. And the idea is that SW Precache should drop into your existing build process and then kind of use wildcards to identify all the resources that make up your app shell. So you kind of give it some information, some configuration information about where your files are, and it'll pick up your files that are generated by your build. So there's, in addition to the gulp integration, it's not even really like a gulp plugin. It's really just we release this as a JavaScript, as a node module, and it's have examples for dropping into gulp. But somebody also wrote a Webpack plugin, which is super nice and maintained by a member of the community. There's also a really cool command line just interface that does the same thing. You could reconfiguration, from external file, and you can just drop that in to the end of your npm build scripts. So some gulp graphics for the meantime, though. All right, so let's take a look what happens when your build process includes SW Precache. So we got a set of local files here, nothing too controversial. We got it like PNG, we have some JavaScript, we have some CSS. So perform our gulp build, it includes a step that runs SW Precache. And we have SW Precache configured with wildcards to match all those local files. And what I'll do is calculate a hash of each of the files that it finds and generates service worker code for you that contains a URL for each file, along with the current hash, along with the install and the activate and the fetch handlers for you. So it contains everything that you need to both like pre-cache all those files and also manage the cache and kind of follow the best practices for making sure that your cache stays up to date as your local files change, as you like add things to your CSS, or your images change, or you drop in new images and things like that. This is the way to do it. I'm personally responsible for maybe some of the bad practices out there that I've seen with people writing service worker code, where you kind of just have like a list of like an array of things that you want pre-cached when you write your own code. And I wrote some of those early examples. It's fine, but then you are like in production scenarios and you're like, oh, what about the fact that we just, renamed our PNGs with this prefix or moved everything around and we forgot to update our service worker code? Or what about the fact that we changed one line in our CSS file and we forgot to like bump that version identifier and things like that? All these things are just, for folks who haven't played around with manual service worker code, these are ways that things could go bad. So this is some tooling that will help prevent that, basically. And so the idea is that when the user initially visits your site, everything that matches those patterns is pre-cached, whether it's actually requested on that page or not. So this gives you the ability to cache things that are going to be used later on by other pages. Is that a question? Sure. Mhm.
I feel like 2 months is actually
Sure.
maybe if I missed this. So the hash, are you
Mhm.
somehow comparing that to the current version on the server? Are you doing some sort of like head reflection to try to get the
No.
Because you're trying to make sure you get the most current version.
Yeah. hmm
You kind of do it in the background
Yeah.
without messing things up, right?
Yeah.
So kind of what's going on, I guess, to do that hash comparison? Because I've been thinking about like cache control
hmm
header and things like that. You know, like those pieces.
Yeah. So in this particular case, so first of all, let me, I'll talk about this a little bit later. This is all kind of supplementary to any sort of caching best practices that you're hopefully already doing. Like most folks nowadays already have realized that like including fingerprints in your file names and setting proper HTTP cache headers are a good thing. This is this supplements that in many ways. And what the logic in the generated service worker will do, it will kind of interrogate the cache that is specific to the service worker and is kind of separate from the HTTP browser cache, and it'll look at the entries that are currently in that cache and compare the hashes for those entries with the hashes in what's effectively the
Okay, so
manifest.
the,
It'll make
the browser's cache. Is that what you're
Well, I
saying?
don't want to say it's a browser cache because there's the HTTP cache that folks are probably familiar with already because like the
The
cache control
traditional
headers.
browser cache.
It's not looking at that at all.
All right.
It is looking at a cache storage API. So there's a brand new API for interacting with this cache in a
I see what you're
programmatic
saying.
way.
So this gets generated, creates a new service worker, which then compares to what's currently in cache and goes
Yeah.
out and gets the different.
If anything is different, if anything's been removed, because it's effectively like a manifest that's embedded within the service worker file. If it sees, there's a file that is currently in the cache but it's not in the manifest anymore, it will know to delete it. If there's anything that's not there or has a different hash, it'll know to fetch it again. One of the nice things, and a little bit of a digression, but it's one of the ways you could shoot yourself in the foot when you're implementing a service worker by hand. One of the nice things that SOV Precache's service worker will do is that unless you opt out of it, it will cache bust the request to repopulate your service worker cache, which is actually super important because the interaction between the HTTP browser cache and requests made by the service worker are things that is really non-obvious, and you could end up like having a different hash in your manifest, have your service workers install handler say, hey, I need to request a new file from the network, but because that particular file maybe doesn't have like a unique hash in its file name, and maybe you're like deployed on GitHub pages and don't realize that everything gets cached for 10 minutes, regardless of what you want to do. You end up like fulfilling what really should be a request for a new file with the version that's already in your browser cache. Getting a little into the weeds here, that's something that is really unfortunately not obvious, and a way that you could get into trouble unless you're doing the things that has to be pre-cached does for you. So, but yeah. So updates, we talked a little bit, got into that a bit just now, so that actually led into this. When you're updated, things change, your hashes change, and then you'll get new stuff in the cache, basically, like we just said. All right, for folks who prefer the command line build process, we have like ability. You don't even have to install it globally anymore. You kind of just install it locally and run it from npm scripts, and kind of run and take a good read-in configuration from a command line. Sorry, like a command line flags or from a config file, but also just has some sensible defaults if you want to just run it, and you see that sort of stuff. All right, so let's dive a little bit into the configuration. Hopefully this is readable for folks. Doesn't look too bad. And just take a look in the particular case of our sample app, how I'm using SW Precache. So first, and in our case, super, super important. Anytime you're doing something that this is also something that's kind of difficult to do by hand. But if you're dealing with a situation where you want to cache like your application shell HTML, and the HTML isn't necessarily like a single file on your file system, because it like the contents of the HTML depend on multiple files that are pieced together via some sort of server side process or just any sort of templating at all. That gets really tricky. And you kind of deal with this situation where you have these like synthetic URLs, or in this case, we kind of call them like dynamic URLs. But we have a way of dealing with that with SW Precache. You basically say, okay, here's our /shell URL, and the contents of /shell are uniquely defined by everything that matches these patterns. Like basically everything that matches the JS, everything that matches like the all whatever CSS, and everything that matches like the index.handlebars file that we're using for templating. So the hash that gets generated for the slash shell entry in the manifest will be unique for the current state of all of those subdependencies. And like if I were to change just my CSS, even though I hadn't changed like index.handlebars or I hadn't changed any of the JS files, it'll generate a new hash for the slash shell resource. And this just means that, you know, it's kind of a way of working around doing this dynamic templating in the server. So that's what's going on there. It's a little complicated and not completely obvious why you might need to do it until you are in a situation where, oh, I do need to do this. And then you're hopefully happy that you don't have to do it yourself. All right, another thing that is kind of not obvious until you start actually writing code that does this, and is a little bit annoying to do if you're writing service work by hand, is this navigate fallback option. This is basically your way of saying to the service worker, anytime there's a navigation request, and you do have the ability in the service worker to like take a look at the incoming request in your fetch handler and see whether it's a navigation or whether it's like a CORS request or like a same origin request, things like that. There's different categories. You could basically say, anytime there's a navigation request, regardless of what the URL is, let's just spit out the contents of what I have in slash shell. And this is a way that you get the app shell to the user, regardless of where they're navigating to, as I mentioned before. So that's what we're calling navigate fallback in this particular configuration. And next little bit over there, static fog globs. Apologies for some of the names here. They seemed relevant at the time when I came up with them. But the idea is like these are all your static files, and they're glob patterns that match the things that you want to get pre-cached. So it lets you individually cache kind of like the resources on your page. Not this isn't what's going to end up caching like the HTML, but everything that matches like your JS patterns, your CSS. If you have images that you want pre-cached as well, you can put anything you want in there. And finally, we have this import scripts options. This is one way of interacting with SW Toolbox. We kind of have some shorthands that make it easier to use SW Toolbox in a very basic way with SW precache. But there's also this flexibility of putting in import scripts here. And this just lets you specify any external JavaScript that'll get pulled into the service worker and run within the context of the service worker, which is useful in our case for SOV Toolbox, but it's also useful if you're like doing push notifications, for instance, which also rely on the service worker, and you need to have your own kind of logic to do that. So you can pull in a JavaScript file, even though like SW precache is what's generating the top level JavaScript file for you. You have the ability to pull in that extra code. All right, so that's a good segue into description of SOV Toolbox, which is the second library that we have. And this is, it's blue. Hopefully you guys remember the color concept from before. So this is for like all the dynamic content in your web app, the stuff that's not your app shell. So SW precache integrates with your build process, but SW Toolbox is loaded into your service worker at runtime. And this is all code that executes at runtime. And folks might have seen articles talking about different caching strategies. One of my colleagues, Jake Archibald, does like the canonical offline cookbook where he just lays out a ton of possible ways of dealing with caches. So I've stolen a bunch of his images here, and I'll walk through some of them with you. That's things that you might want to use. So one strategy, for instance, is to use the cache first with a network fallback. And the cache here, and the cache in all these images, we're talking about this dedicated cache that the service worker has access to, not the HTTP browser cache. So the idea here is that you have a page making a request. The service worker sees the request. It tries to go to cache first. You could say like do like cache.match, basically, pass in the URL. Either it'll get a response back from the cache, in which case, great, just pass that back to the page. Or cache.match might return undefined or null or whatever it returns. And then in that particular case, what your service worker could do is go to the network. It's not like you have one shot or anything like that, where you have a cache miss and then you just give up. You have the ability to have this fallback logic in place and say, okay, fine, I'll go to the network. And maybe I'll take that response from the network and I'll use it to populate the cache so that next time you request the same URL, I actually have something and I don't have to go to the network. is great. Um, so this is a good strategy where you go to the cache first to deal with resources that are very unlikely to change, like static images that have a unique URL, or really like anything that has fingerprints in the file name, where you know that it's safe to take the previously cached response and reuse it because you're not going to have the same URL with different content that gets swapped in or anything like that. And we have some, yeah, so then we have toolbox.cache first. It's kind of like a helper implementation in SOV Toolbox that'll do that for you. So another approach you might want to do, kind of the opposite, is to go to the network first. Maybe you're offline though, so it tries to go to the network request fails, and you could then say, okay, I would like to fall back to whatever my previously cached copy is. And this is a really good strategy to use when you're dealing with data that needs to be as fresh as possible. So ideally, you want the network response, but you still want to display something when the network is unavailable. So maybe you're a social media company and you're displaying some timeline information and you want to get that network copy, but still show something to your user when they're offline. This is the type of strategy you could use for that. And it corresponds to toolbox.network first handler. And finally, here's kind of an interesting strategy where the service worker kind of fires off a network request and a request that goes against the cache at the same time. So the cache response will normally come back first because it's a cache and it's probably faster in your network. And that response will get returned directly to the page. But in the meantime, the response from the network is used to update the previously cached entry, keeping things relatively fresh. And this is done in the background without blocking the rendering of the cache content. So your page gets cache content immediately, but your caches are kept up to date. It's basically like stale while we validate, more or less. But for whatever reason, we're calling it a toolbox.fastest because it's kind of like a race between the network and the cache, and whatever is fastest will be returned. Excuse me. All right, so it's really important to take some time to think about which strategy is most appropriate for the dynamic resources that you're using to populate your app shell. And you really don't have to just choose one strategy. SW Toolbox has this routing syntax that let you apply different strategies to different URL patterns. So you could do things like toolbox.router.get /images, anything that starts with /images, use the cache first handler. You could say /API, I want network first, and you might want to use fastest for /profile. So you really have to understand your dynamic requests, and understand your network traffic, understand what your URLs are like. Hopefully, everybody understands that. If you're the one deploying this web app, you own all this stuff. There might be surprises. It always helps going and like checking the network panel in the Chrome DevTools or whatever, just to make sure that there aren't like these HTTP requests that like some dependency of yours is making that you didn't realize were happening and aren't being matched by one of these. So just spend some time looking at your network traffic and thinking about what the right strategy is for each type of traffic. All right, so you could kind of implement some of those caching strategies yourself, though. As I mentioned, my colleague Jake has a great article with code for each one. So why use SW Toolbox? There are a few extra things that you get from using SW Toolbox that kind of help solve the problems that arise in the real world, in actual like production web apps, and they deal with things that you probably don't want to deal with yourself. So first of all, Li-Fi, talked about it before. The idea is you can just opt in to specifying a little bit of additional configuration here. We have our same same network first strategy for this type of request, but we're putting in an additional configuration option here for SW Toolbox saying, I want a timeout after 3 seconds for my network request. So this will basically, the service worker will make its request, at the same time kick off basically like a set timeout. If that fires before that network request comes back, it'll return the copy that was previously cached directly to the page. So you do have like an upper bound on how long you're willing to wait, which is really cool for those live file scenarios in particular where things don't fail right away. It might fail after 30 seconds or whatever. It really depends what, if data is trickling in, it really might not fail for quite a while. So this does give you a little bit more control and a very easy way to opt into using that. You can see that there. So another thing, and this is super, super common for folks to run into, and it's a real easy way to shoot yourself in the foot. You might have page-specific content like images associated with each page the user visits, and you know you might want to cache those. Depending upon how your site works, like in my case with this demo, the iFixit API, there are maybe like 4 or 5 images on each page, and it's nice to cache those. I'm not going to pre-cache those because I don't know the user is going to go to a given page, so it really doesn't make sense. And honestly, I don't even know the URLs for those images ahead of time until I make the iFixit API request. So I'm not going to like pre-cache those and necessarily pre-cache, but I want to have some runtime caching so that once a user does browse to the page, there's something kind of sane going on and the ability to like go back to that page later on without a network. Um, so you could do that pretty easily in a service worker. And if you keep adding to your diamond caches indefinitely, though, you're going to just keep up using up storage on the device. And because there is this kind of like separate cache storage API, it is separate from like the expiration logic that you get with the browser's HTTP cache. You might be used to setting those headers and then thinking, okay, well, my content's going to expire eventually. And that's true for the HTTP cache. It's not true for the cache storage API by default. So what you could do with SOV Toolbox, though, we take care of a lot of the accounting for you, and we give you the ability to do things like say, I would like a maximum size of 6 for my images cache. So you have like this dedicated cache for images, and once it reaches 6 entries, it's going to evict the basically least recently used entries from that point on. And we're taking care of like doing some index DB accounting of when the things were actually used in the background for you and some stuff that's kind of a pain to have to write yourself. So you could get it for free more or less just by opting into using that in SOV Toolbox. Hmm.
There's my knowledge, there's no cache spec that says
Hmm.
I'm hurt.
Hmm.
Got a feeling that browsers are going to randomly more or less purge content out of the cache
Hmm.
as resources.
Yeah.
Seem to have a strategy that's common knowledge there.
Yeah, I mean, it's not anything super secret. It's somewhat not well specified, I guess, is the main reason why there's confusion about it. Not because we want to, protect developers or users or anything like that. I think the basic idea. So this is more of an issue because it's a lot easier to fill up your cache with the cache storage API by just doing runtime caching. But it's always been an issue for things like filling up your storage quota with IndexedDB. Like you could write a lot of stuff to IndexedDB, you could write a lot of stuff to local storage. If folks have previously used app cache, you could write a lot of stuff there. So this is a concept that's been around for a while. What a browser will do when it thinks that a particular origin is using too much storage. And it is somewhat opaque what the actual limits are, and it depends on how much free storage there are. It depends on what platform you're on, and the browser will try to make some estimates. We're trying to expose some APIs for actually interrogating that information from your code, but those APIs aren't around right now. But the general idea, though, is that we want to expire everything en masse, basically, just like in one go. So we don't want inconsistent caches. We don't want to just like Chrome, at least, is not going to take like 10 image entries and say that they're really big and say, okay, I'm only going to expire these 10 entries, but I'm going to leave everything else around. Because we don't really know how you're using your caches, and doing that really might screw things up for you. So the general idea is that it's going to expire everything. It's going to unregister the service workers. It's going to clear out all the caches, clear out IndexedDB. If you really do get in the state where you're using too much storage. That being said, there's also kind of like proposals for an API to request permanent storage, which is something that people expect from native apps, certainly. And there's similar criteria to like what we look for when we show the add to home screen prompt. It might actually be like things that have gone through the add to home screen flow. The user implicitly wants that thing to stick around. So those things might be auto opted into permanent storage, and they might, like the browser might decide that we're not going to clear out this stuff.
Like some
That's good.
platforms let you see some of the features that they have once, but sometimes they'll
Yeah.
check what they have once.
Yeah, it'd be really, really nice to have that level of integration on all the platforms. Part of the problem is like you could look at that for Chrome and you could see all the permissions for Chrome, but like on Android, for instance, and it's like treated as like, okay, this is how much space Chrome is using if you look in the Android system, UI, and Chrome has notification permission, but built in with the Android, again, I'm talking about Android in particular, UI, there's really not like a per origin way of viewing it. Like if you go into Chrome, there's ways of checking per origin how much space is used and what permissions are using, but we don't have like those hooks into the Android system tools for doing that same sort of thing right now. So kind of long-winded answer. Hopefully that clears up some of what you're talking about and having to chat more about it. I got like the wrap up from Sergey about 10 minutes ago, so we'll see. There's a lot of stuff here. So take a quick look about the configuration we're using for SOV Toolbox in this particular sample. All stuff we talked about before, we kind of like, okay, we want to use the fastest strategy for our actual iFixit API requests. So it'll get something to the page right away, it'll get updated in the background, and the next time you visit the page, you'll get that previous response in a stale while we validate fashion. Where we have this fallback logic in here, which is another nice thing you can do with a service worker. You could say, regardless of what request I'm making, if the network's not available, then use my like placeholder image instead of like Chrome's default missing image. So we're kind of pre-caching our own placeholder, and we're using that when the request fails. And finally, we're like doing the same sort of cache expiration, cache first stuff for all our images I talked about before. In this particular case, this actually works for cross-origin requests too. So like all the stuff iFixit is using is served from CloudFront to .NET. That's fine. Service Worker can cache those requests as well and use them, for image tags. Yeah. All right, so not all browsers support service workers. You might be able to guess which ones don't. So going back to our analogy, it's possible to kind of like land planes at an airport without an air traffic controller, but you're probably going to want to do it very slowly and deliberately, and it's not going to be as fun for the plane's passengers. So same sort of deal, like if there's no service workers. And how do you treat service workers as progressive enhancement? How do you make sure you still have an experience that works on browsers that don't support them? If you remember, the first time you visit your web app, there's not going to be a service worker in place yet. So you're kind of forced to think about this experience, even in browsers that do support service workers, because it just hasn't installed yet. So you need to make sure your web app renders properly without service workers anyway. On browsers that do support service workers, though, the next time people visit your web page, you can take full advantage of everything the service worker has to offer. But for browsers that don't support service workers, next visit to your site or web app kind of looks very much like that initial visit. It's just not going to go to the service worker. It's going to go directly to the network or to the HTTP cache. So your architecture shouldn't really have to change in order to accommodate browsers that lack service worker support. And those caching best practices that hopefully is ingrained in everybody's head for dealing with the browser's HTTP cache still apply. So continue to add hash fingerprints into your file names and use like far future HTTP cache expiration headers for static content that's not going to change. And STW precache will happily work with that setup. Yeah. All right, so now you have the keys to unlocking the performance wins for browsers that do have service workers. You avoid that 423 milliseconds, get that down to 5 milliseconds for the subsequent navigations. Do that same for server rendered pages. Okay. Next steps though. So embrace your app shell. Folks, like I'm not sure whether app shell is actually terminology that folks use outside of the Google bubble. You might already be doing stuff that's pretty much the same sort of architecture. Hopefully this is not like completely rethinking the way your app works. And the specifics depend a little bit on if you're using a framework, what that framework does. But the concept is definitely framework agnostic. So your next step might just be to add in a service worker to your existing web app using SOV Precache and SOV Toolbox libraries, hopefully, if they're useful to you, or writing it by hand or any other way. Um, but if you're starting from scratch, you want some inspiration, you want to see a kind of like finished real world demo, have the source code up there and like a live demo that you can go to check that out. It's this particular demo is using React and it's using universal JavaScript, so it's doing some server-side rendering and that sort of stuff. So if you want to see an example of that, it might not be the best, most canonical for React code, but it's it was what I was able to get working. So we also have this kind of pretty cool code lab for folks who like code labs. My team has been doing a lot of code labs and have this like environment. I'll walk you through different steps for kind of taking a pretty basic web app and just adding in the service worker using SOV Precache. So we have that there. Web Starter Kit is a pretty cool project that some of you might have used already. SOV Precache and SOV Toolbox is built in for projects that start with a newer version of Web Starter Kit. It's actually been there for about a year now or so. So you might already be using it if you've ever done anything with Web Starter Kit. Another really cool thing, I've been playing around with this. This is somewhat unofficial at this point. If you're a React fan and you've played around with Create React app, it's just a really nice way of scaffolding brand new React apps. So it doesn't take much effort to take the output of Create React app and turn it into kind of a progressive web app and adding a service worker and things like that. What I've done is kind of put together this repo that has the initial version that you get right out of the box, and then just the very minor changes that you need in order to add in SW precache to the end of the npm scripts build process and a few other things like a manifest. So very minor changes, and you could get yourself in a position where you have a React-based PWA with a nice starting point. And yeah, we have the site. Google's web dev team is really all in on progressive web apps. We want to have a lot of good content for folks. We're trying to collect it at this landing page on our /web website. So check that out. Lots of links to videos and code labs and articles and hopefully everything you need to go beyond what I talked about today and actually build this stuff. So yeah, thanks so much, Sergey, for inviting me tonight. Thanks for you being here. Yeah. Hopefully we have time for questions. I don't know. The question was, how does this relate to Angular 1, Angular 2? What's the general, I guess, like PWA type story for those frameworks? So first of all, like the libraries I was talking about today for like adding in the service workers, pretty much agnostic to whatever framework you're using. So you could theoretically just add that into your build process, and if Angular might have its existing process for spitting out some stuff, and then you could cache those things if you wanted to. That being said, you do get some benefits if you're actually knowledgeable about how the framework works and the way the framework's doing things, and make it so that the build process that is in place that might be specific to like Angular CLI or something like that could do things that you would not necessarily get if you were just dropping SOV precache in. So this is something I know the Angular team in particular has been thinking about mainly for Angular 2 nowadays. And I don't think it is on by default in like their Angular CLI experience, but I know that they have been like behind a flag or might be in a separate like fork of the repo, been playing around with their own generated service worker. So it's not actually using SOV precache or toolbox. It's using a lot of the same concepts, but it does things that just take advantage of knowing how Angular operates and kind of like the pre-rendering that Angular does and what paths it expects and things like that. So the idea is this is ideally something that you will be able to get in the future just by using Angular's CLI tools when you like scaffold out a new project, and it might be available behind a flag right now to check out. So for the Angular 1 front, I don't know, and I don't want to speak authoritatively for the Angular team. I don't know that they're working on official tooling there. So I think that what you probably should do if you are on an Angular 1 code base is try to just take precache and toolbox, or take, there are a few other tools out there that do similar things, and just try to add them in basically to the end of your build process so that you have the output generated from whatever the build is, and it will cache those files for you. It'll load them from the network and it'll version them. And hopefully it's kind of agnostic and might not be quite as nice as the full integration, but you should be able to get some. Yeah, so I work for Chrome. I can't really, so the question was about the story for iOS and iOS Safari in particular. So iOS Chrome does not have the ability to use service workers, unfortunately. iOS Safari, I work for Chrome. I can't really speak on behalf of Apple. I know that people expressing interest in service worker support and progressive web app concepts in general would probably be useful in making sure that Apple realizes that this is things that people want. And I think it's kind of encouraging seeing some of the latest kind of responses that we've seen from Apple in terms of some of this stuff. And we had our Chrome Dev Summit 3 weeks ago, something like that, a month ago. There's some Apple representatives there. So read the tea leaves as you will. Yeah, that's the basic story. But yeah, there are no service workers supported on iOS right now, though. So the same concepts that we talked about, doing things like, especially taking advantage of HTTP browser caching. It's not going to help your initial navigation, but for loading in all of your assets and things like that, it's still super important and good practices. No, it doesn't. Yeah.
Can you repeat that?
Yeah, sorry. The question was whether Service Worker has the ability to kind of intercept WebSocket requests and proxy those. And the answer is no. It's really just focused on HTTP requests. So the primitives that you get is kind of like this. It's part of like the fetch spec. If folks have played around with fetch before, like there's the concept of a request object that is basically like a serialized version of a request, and it has URLs and things like that, and the HTTP method. But and that's what gets passed to your fetch handler, and then you could create a response either from the network or from the cache and that sort of thing. But there's no kind of like way of intercepting WebSockets and doing the same sort of stuff for those. By the way, if you're debugging WebSocket stuff, you might run into this. When you try to simulate being offline in Chrome DevTools, that offline simulation does not apply to WebSockets. So you might think that you are trying to like, okay, how does my web app work when I don't have a network by using Chrome DevTools? And it works great. And you're like, oh, wow, my service worker's magically handling all my WebSocket traffic. And it's just because it's not. So just, turn off your Wi-Fi, basically, to simulate failed WebSockets. Yeah, so Firefox for Android and Firefox in general in general, not on iOS, has support for service workers, which is great. And things, in the early days of service workers, both in Chrome and then in Firefox's implementation, things were a little hairy and there were lots of bugs and incompatibilities. Things have really smoothed out at this point, and it's been a while since I've seen any like weird bugs due to using Firefox versus using Chrome. And same for Opera, and Opera is using the same underlying kind of underpinnings as what Chrome is using. And yeah, and I think Microsoft has been pretty public. We didn't talk about Edge, but Microsoft has been pretty public in terms of getting close to supporting service workers. And I think there are flags in like some of the developer previews of Edge that you could use to.
Okay, thank you, Jeff.
Cool.
Thank you very much.
Thanks, everyone.